Hello and welcome to JHEPS and World of Ed's lesson on sequences and series part 2, series and sigma notation as well as arithmetic series. So again, this is suitable for AQA Core 2 and EdXL Core 1. Geometric series will be under Core 3 and binomial expansion would be under part 4. Yes, I think that's all I've got to say. So first of all, we come to series and sigma. If you remember from the first part of the lesson, we had a lot of numbers, we had some sequences and we tried to find out general term for them. But if we wanted to add them up, there is a special notation that we write to stand for series, because a series is the sum of the terms in the sequence, and that is notated by Sn. Okay, S standing for series and N standing for the number of terms. So that means if there are 5 terms, I would write S5. If there are 10 terms, I would write S10. So for example, I'm just going to write 4, 6, 8, 10, as you will see in a minute. 4, 6, 8, 10, 12. If I wanted to find out the sum of the 5 terms here, that's 1, 2, 3, 4, 5, that would equal the sum of the first one, plus the sum of the second one, plus the sum of the third, plus the sum of the fourth, plus the sum of the fifth. Okay, and that's what we're basically saying. Now there's another one. There's another sign that you need to learn as well, and it's more useful than that. It's actually sigma, and sigma just basically looks like this. Sigma looks like, oh, that was a horrible drawing, but it looks like that, and that basically means, oh, and that was wrong as well. I was supposed to write U instead of S, because that wouldn't have made sense in the first place. I was supposed to write U instead for the 5th term, the 4th term, the 3rd term, the 2nd term, and the 1st one. There. And sigma is just basically standing for the sum of. And if you wanted to find out what the sum of all these are, we would write it like this. I'm going to explain to you, so don't be baffed out when I write it. It would be like that. It would be 5r equals 1, and it would be 2r plus 2. Right. So this is how we write it, and this is the basic framework, this basic skeleton, as I say, in which we format this. For example, general formula. So let's go through it. As you may see, you saw an R here. This R doesn't, it's not anything different. It's just another way of writing N. So what we are saying over here is the total sum of the number of terms from the first term to the last term is this, and then substituting it into this formula. And these are all part of a finite series. A finite series means that it stops at a particular term in the sequence. Infinite is when it carries on and on and on and doesn't stop. Okay, so let's say, for example, I've written here, if I wanted to find out the sum of the 5 terms in this sequence, I would find out the sum from the first term to the 5th term, and I would substitute each and every term into R. So that would be, let me start with 1. So 2 times 1 equals 2, plus 2 equals 4. 2 times 2 equals 4 plus 2 equals 6. 2 times 3 equals 6 plus 2 equals 8. 2 times 4 equals 8 plus 2 equals 10. And last one's 12. As you can see, it's exactly the same as this. It's because in the exam, they may not even give you this. They may not give you this series, this sequence to formulate this sigma. So you might just have to do it the other way around. You might have to use the summation and the sigma notation to actually build up the sequence, and then you can add it. And I calculated this like Blue Peter, and I found out that it comes to 240. So S5 equals 40. Okay, so the summation of all of these terms equals 40. By the way, R, you can write N if you want. This is just a general formula. If you can't remember what the general formula is or how to calculate it, I suggest you go back to part 1. Okay. So remember, this is the last term that you want to find out. This is the first term you want to find out, or the term that you start with, because they may just say start with the second term. They want to find out how far it is. What's the sum from the second term to the fifth one? So therefore, it will be R equals 2. So, like I said, yes, and also you may come across a time where they may have plus 4, minus 6, plus 8, minus 10, plus 12, where the operations are alternating. There's a plus here, minus here, plus here, minus here, plus here. All you just need to do is do exactly what you did here, but in front of this, just write minus 1, and you started with a plus here. So you've got R plus 1. That's all you need to do. The reason why we write this is so that it gives us an opportunity to decide whether it is and whether the operation is minus or plus. So let's say, for example, we've got the first term here. So summation from R equals 1. So minus 1, R plus 1, and 2R plus 2. Yeah. So let's say, for example, we want to find out what the first term is. Remember, we always substitute R for 1. Well, if we want to find out what the first term is anyway. So, minus 1, 1 plus 1 equals 2. So that will come up as minus 1 to the power of 2. And as we know, minus 1 to the power of 2 makes positive 1. And then we just substitute 1 into here as well. 2 times 1 equals 2, plus 2 equals 4. And that will equal positive 4. That's the only reason. That's just the basic rule of thumb if you've got alternating signs. So for the next part is arithmetic progression. So say, for example, if you've got 2, 4, 6, 8, who would you appreciate? We automatically just know. We automatically know what the next term is. We know that it's 10. But what about if you're trying to teach a baby how to do this, or just, I don't know, an illiterate mathematician who's doing an A-level? What you need to do is you need to be able to define what an arithmetic progress is. I think Edexcel, you probably do need to define it, but for AQA you can get away with not defining it. But our arithmetic progression is a sequence of numbers where the next term can be obtained from the current term by adding a certain number, and this certain number is called the common difference, but I'll come to that later. So we know, let's say this is the current term, right? And we want to find out what the next term is. Well, we can find out what the next term is by finding out what is the common difference. Common difference, it means what number do you need to always use to get to the next number. So if we say, for example, to get from 2 to 4, it's plus 2. To get from 4 to 6 is plus 2. To get from 6 to 8, that's plus 2 as well. So this is the common difference. These numbers are common, so therefore that's the common difference. Okay, and I should write that here. Common difference. Okay, and that means we can find out what the next term is by using that common difference. So we add 2 onto 8 to make 10. Okay, in a more mathematical way, common difference will be 4 minus 2 to make the difference, but you know, a bit too ropey for me, to be honest. Also, there is a general formula in which to actually write all of this in, and you do need to know it, but fortunate for you, it's in your formula books. It's in your AQA formula books right over here, and I'm going to explain that in a quick sec as well. So there are 2 letters that you need to know for arithmetic progression, and they are A and D. A stands for the first term that you are looking for in your sequence, and D means a common difference. And in order to do that, in order to actually find out what the next term is going to be, what the last term is going to be, we use A plus n minus 1 D. Okay, that is, and it's right here in your formula book as well, un equals a plus n minus 1 d. You can write un as well here. I'm going to explain that. So say, for example, we use 2, 4, 6, 8, 10. Let's use that. 2, 4, 6, 8, 10. The first term is 2. The second term is the first term plus 1 lot of the common difference, which is 2. Okay? The third term is the first term plus 2 lots of the common difference. The fourth term is 2, the first term, plus 3 lots of the common difference. When I mean 3 lots of the common difference, I mean, 3 times 2. If, for example, we've got Smarties, right? I have 1 lot of 2 Smarties. Let's say, for example, the Smarties in the packet, there's 2 Smarties in the packet. So I've got 1 lot of those 2 Smarties in the packet. I've got 2 lots of those 2 Smarties in the packet. And I've got 3 lots of the 2 Smarties in the packet. And that is for the fourth term, third term, second term, and the first term. Now, in other words, we can write this as 2 plus 1d, 1 lot of the common difference, 2 plus 2d, 2 plus 3d. And this is for the fourth term. To get from this number to this number, we need to subtract 1. And this is where the minus 1 comes from. This is the term, this term, minus 1 to give us this term. Okay, so that means to get from the fourth, to get to 3D, it will be 4 minus 1 d. 4 minus 1 is 3. 3 times d is 3d. And that's how we've got this a plus n minus 1 times d. And that's how you find out the nth term. For arithmetic series, we need to actually we can actually find out what the sum of all of this is using a special equation. But first of all, I want to tell you about a story about, it's not going to be that long, don't worry. I want to tell you about a story about a man, well, a student who actually counted the first 100 numbers in a matter of seconds because his lazy teacher didn't want to teach them. And he did it using this rule that I'm going to help you with now. So we've got 10 numbers here. To add them all up, we can do 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. But that's long. It may not be long for now, but when we've got 100 numbers, it's really long. Or we can pair them up. We could do 10 and 1, 2 and 8, 2 and 9, sorry, 3 and 8, 4 and 7, 5 and 6. You may be thinking, whoa, shouldn't it be 1 and 9 or 10 and 0, 9 and 1, 8 and 2, 7 and 3, 6 and 4, and 5 and 5, but there's no 2 5s. There's no 2 5s, so we can't really pair them up. So we use the numbers, we use the first and the last numbers, and we pair them up going inwards like that. So as you can see, there are 5 pairs of numbers, right? 5 pairs of numbers, and they all equal, each pair equals 11. They all equal one more than the last number, and that's going to be really important when we're trying to find out what this what the general equation actually is. And to do that, we need to also there are 10 terms here. If you may not have noticed, there are 10 terms. So what we will do to get from 10 terms to 5 pairs, we need to divide it by 2. So we've got n over 2, and that gives you your amount of pairs. Okay, so that gives me 5 pairs. Now we need to be able to get 11. Okay, we need to be able to get 11. So it would be the first term plus the last term. And that's it. That's how you find out what it is. You've got the 5 pairs, you multiply them by 11, and that gives you 55. You can even go and try it. You can type in 1 plus 2 plus 3 plus 4 all the way up to 10, and it will give you 55. Or you can add the first term and the last term and times it by how many pairs you've got. Okay, because each pair adds up to 11. And since there's 5 pairs, 11 times 5 equals 55. That's important. That is also in your formula books, lucky you, and lucky me as well, because I'm taking this exam. But what about if you don't have that last term? For example, let's just pretend that we don't have 9 and 10, okay? And we need to be able to find out what these two, well, we just need to find out what the 10th term is without it being too much of a hassle. So what we would do, what we would write instead is n over 2, because we know that there are 10 terms here, so we can do this. But how would we find out what the last term is? Well, we actually use this. We actually use the a plus n minus 1d rule to find out what the last term is. Because when we did that over here, we could find out what the last term is for 2, 4, 6, 8, and 10. We did the first letter plus the term minus 1 times by the common difference. And we can actually use this here. We can do a, okay, we're still using this, plus, and then import the arithmetic progression formula here, a plus n minus 1d. And that's how we do it. We can also collect like terms, so we can end up with n over 2, 2a plus n minus 1 d. And that would actually, should be in square brackets, but okay. And that is actually how we would find out what the last term is, or the sum of all of it without finding out what the last term is. It's up to you. So let's pretend that we didn't know what the 10th term is, and we did 10 divided by 2 because we know that there are 10 terms here. We divided by 2 to give us 5. Then we, that's supposed to be a square bracket, by the way. Then we do 2 times the first number, which is 1. So 2 times 1, which is 2, plus 10 minus 1, the 10th term minus 1, which makes 9, times it by the common difference, which is 1. So let's actually make this a bit clearer. So it'll be 5 bracket 2 plus 9. Multiply it. 5 times 2 is 10. 5 times 9 is 45. Yeah, it is, yeah. 10 plus 45 equals 55. And that is the sum of the 10, all of the 10 terms. Okay. Now, say for example, we've got, by the way, this is the end of the lesson, but I'm going to do one more example, so stick around if you want to. So say for example, we've got 5, 7, 9, ... and we want to find out the sum of all of it up until the 26th term. What we will do is, first of all, we look at the formula booklet, and look, it's right here. We can use either this formula here or this formula here. We're going to use this formula here, okay? Because we don't know what the last term is, so we're going to use, I can't even highlight it properly. We're going to use that formula. We're going to use this formula right over here. So remember, n over 2 is exactly the same as 1/2 n. Okay, so don't get mixed up when you see that. Right, let's get started. So first things first, we write it down, and then we substitute n for 26 because there are 26 terms. So half of 26, or 26 over 2, bracket 2 times a. The first number is 5, so 2 times 5, pardon me, plus 26 minus 1, because we got 26 terms, we minus 1, times it by d. The common difference is 2. Alright, you can't see the first number, sorry, it's 5, by the way. 5, 7, 9, there you go. And that is 2. So we've got 13 bracket 10 plus 25 times 2, which is 50. 13, 10 plus 50. I'm just going to, read it from there. Multiply out 130 plus 650 by my calculations. Then we can add it together, and that makes 780, and that is the sum of all of the terms here without actually even needing to find out what the 26th term is. If we wanted to find out what the 26th term is, what we would do is we would actually use that formula. We would use this one, but we would actually write it like, where is it? We would write it like this. Over here. Okay, we would write it like this one over here, where we've got the a plus n minus 1d. And that is the end of arithmetic sequences.